This is an SGE detector box. These points are out of use, but just to show you, there's your FPL there in the middle of the track, and your rods from your far rail, your FPL and your near rail that come across. And on the tail end, the rods come back under, up and round, and these locking nuts should be up against here, but the whole thing's out of use. This rod is actually threaded, so this shouldn't have a nut on the back of it. It won't come off. It is actually threaded. You have to unthread the whole bar. That's what this nut's for, actually, because this is bound up against that. You should be able to just unwind it. But these act as locking nuts. These act as your adjusting nuts, and then you've got these to tie them onto the bottom, onto your other rods. Just brace down on the metal strap across the timber ends. Really should have two of them. SG detector box, cast iron top, cast iron bottom, and we'll have a look inside. This is an older type of installation for ground frame detection. Now, what you have is your three rods, with your adjusters here. Internally, it's very simple. You just have a pair of flick contacts that go over and back, driven off a central shaft. The central shaft is quite interesting because it actually has little bits of locking in there. So until it's in the correct position, the spring-loaded tappets, this spring here, will not push the tappets in to their notches. As you can see, this one here is in. That gives you one direction, allows it to drop in. So this little bit of locking that's actually in here allows you to get those tappets in the right place. Fairly actually spacious. You can get your cable glands in. You can take cables in from either side. A nut that can actually be removed, so you can take cables in and out. So left or right handed, and it's got a nice simple drop down lid, big heavy SGE detector box. Looking at your actual detection contacts that are driven, as I mentioned, this shaft drops backwards and forwards once the notches are into the tappet rods. So it's fixed here on its mounts, so it can only pivot. The other end is attached into this drive shaft here, so as the drive shaft goes back and forwards, it pulls and pushes this over to the correct position. Rubbing contacts, which you can see, fairly simple. This just clasps around the actual little plastic and brass contactor inside. There's a little pin screw there, little Allen screw, if you can see it, just there. That's what holds that in. Simple oiling points, there's a few oiling points, a couple of little oiling points down there. These holes are your oiling points. Also, you've got them on your incoming channel holes as well. Another oiling point there. It actually says oil on the tappets as well, so you can't miss them. So if you've got them ones there, you've also got some more that are hidden down here that will, when they pop out, they'll say oil as well. Just hidden behind there and there. This is a BR standard detector, more modern type. You take the lid off, you have a 2BA block inside, 6-way terminal block, and the numbers are 1, 3, 4 and 6. On the right hand side they're doubled up in the 10s, so it's 1 goes to 11, 3 to 13, 4 to 14, 6 to 16. Black and yellows are your two terminal straps you'll see on the diagrams. 2 down micro switches, double contacts inside with a rubber enclosure on them. Sometimes the rubbers go on these. Springs behind to pop the leaves back out, and on the end of the leaves are rollers which roll about. Greasing points there, there and there. What you have is you should have your three rods, so you can have your FPL, your left hand switch and your right hand switch rail sat in there. If you've only got 2 rods, use the spacers, which is this block here. That's a spacer block, and that takes up the space of the third missing rod. As you can see, you've got 3 rollers, and what happens is when all your rods are in alignment, you just see down there, your notch is lined up. You should have about 2mm clearance there. There are different rods for back detectors and front detectors. They're not all the same. And the rods come out on the back end, the cess side again, and go back in. Both circuits are cut through it, so if you've got a normal, unlike the other box where you had just a normal made and a reverse not made, you prove the normal's made, and you prove also a contacts in the reverse as well that aren't made. So it's normal made, reverse not made. If it's the opposite way, it's reverse made, normal not made. So just watch it go over. So this contact here will drop out. Watch very careful. See now, it's pushed that in, it's broke that micro switch. And this one's waiting to drop in. And that drops out. So one is closed, one is not closed. And this is not the best diagram, but when you turn the lid upside down, you get this little diagram inside. It tells you whether it's either points normal with the slides out the left or points normal with the slides out the right. If you can appreciate from previous videos, the line straight through means it's locked. The big fat sausage contacts mean it's normal. So if that's a normal, that's a reverse. That's a normal and unlocked, that's a reverse and locked. Okay, and likewise on this side, that's a normal, but it's got a line through it, so it's a normal and locked. That's just a reverse. That's a normal and locked, that's a reverse. So you can see when I said you prove one side locked and one side unlocked. So you're proving that normal is locked, and with a normal locked, you must also have a normal unlocked side. When I mentioned terminal block, this is a terminal block. And there's your two top ones, the blacks and the yellows. Black and white in this case. And these are hidden under these here. I mentioned the circuit diagrams for the standard 998 detector. Now, as I mentioned before, you can see that the big fat sausage contacts are the normals and the thin lines are the reverse. Now you notice it's got an R above it, should have an N, but on more modern diagrams what they have is this little line above it. So if you can just see that little line there, that almost a negative symbol, that means not. So on the older diagrams, common sense, you put an N there, you put an R there. On the more modern diagrams, you put a not R, so it's not reverse, so it's normal, and you put an R for reverse, and again a not normal because it's a reverse contact, and a normal contact. A bit confusing, just got to be careful of those on modern diagrams. So in this case here, if this dissection circuit, these will be the normals, so the normal will come in, it can't get through the reverse on the right hand side, so it will jump up, go to this joining post here, which would be the top right hand terminal you saw in the detector box. So that's the yellow and black terminal, so that's a black terminal. Then it drop down, come to here. You can't go back through that because it's a not normal, that's a reverse contact. And then it go out on the normal contact and off to the detection circuit, and its return path will come back this way through the other normal contact, up to the binding post on the top, which is the top stud I mentioned before, and back out again onto this, and again that'll be the other normal contact and back out. So it's incoming, it's outgoing, and the reverses would be incoming, jump around again, and outgoing in this case. Bit confusing with these not symbols. And also the other thing they don't show on these modern diagrams, as we mentioned, you always have one switch which is, the switch rail is closed and therefore would be normally locked with an FPL if it had an FPL on a mechanical set of points. On these they don't show the locked symbol. So you'd have a pair that are locked and a pair that are unlocked, and again a pair that are locked and a pair that are unlocked. I'll have to find you an old diagram, show you that.